planning a SQL Server 2008 installation. So now we're going to take the information from the previous nuggets and bring it all together in a sort of comprehensive planning scenario. We're going to start by planning the instances that our installation will need. We'll go on to planning its disk storage. We'll look at how to plan for its security. And then finally we'll look at the different ways that we'll plan for its availability so that it never crashes, that it's as available as much as we need it to be available for whatever business needs we have. So first up is instances. Now, we said in the previous nugget that SQL Server is capable of running more than one version of itself, or more than one copy of itself, on a single computer at a time. Each copy of SQL Server is referred to as an instance. Now, there are just a few reasons why you might want more than one instance. So, as you're doing your planning, kind of take it as the default that you're only going to have one instance. That's the default instance. And then look at some of these reasons and see if you can talk yourself in to having more instances. So the first reason is for stability. If an instance goes down, it goes down. Everything in that instance goes down. If there are databases that you know have got problems, maybe you've got an older database that's running some legacy code, you're no longer able to work with the developer to fix it, and you know it's got some code issues that make it crash occasionally or consume too many resources or something like that. Having its database in a separate instance will wall it off from everything else that SQL Server needs to be doing. Another reason is if maybe you don't have full control. Say in a hosting environment, you might want to have each customer in their own instance of SQL Server so that they can't harm or affect what other customers are doing. Reason number 2 is security. Each instance has got certain broad administrator roles. You can kind of think of this as the enterprise admin of SQL. Anybody who is a server admin, it's not really a good term. It's kind of a legacy term. We only used to be able to run one version or one copy of SQL Server at a time, so a server-wide admin had control over the whole server. Well, now a server admin in SQL Server has control over the entire instance. So if Bob is going to be a server admin of a particular instance, and there's one database or some databases in your environment that you don't want Bob to be able to have any control over, those have to go in another instance. Anything in his instance he has full control over. So from a SQL Server standpoint, an instance is kind of like an Active Directory forest. It's the security boundary. Everything within an instance can be controlled at a top level by the instance's server administrators. The other reason is for performance. Now this actually ties back into the stability thing a little bit. But the basic idea is that you can control how many resources a particular instance is capable of using. So if you've got one machine, rather than leaving everything at the default, which is allowing every instance to use as many resources as they can grab, you can choose to narrow down and lock down exactly how much an instance can use, thereby reserving resources for other instances on the machine. Now normally SQL Server is a reasonably dynamic application. It'll grab what it needs and no more, and as its workload goes up, it'll try and grab more resources. You can put an upper cap on how much an instance can use, and that's something we'll be talking about in a later nugget. And the last reason to have separate instances is for configuration. There aren't a ton of instance-wide configuration options. Many things in SQL Server are configured at the database level. So each database within an instance can have different configurations, but there are certain top-level configuration things in the instance itself. One of those, obviously we already mentioned this from the security standpoint, is the server admins. You've also got things like, you've got a lot of defaults, like a default collation order. And that's just the order that SQL Server uses to sort things. Typically, the fact that the default collation is server-wide or instance-wide isn't a big deal because it can be changed on a per database basis. But one of the things that can be a big deal is security, and this goes back to security. So there are two security modes or authentication modes in SQL Server. One is called mixed and the other is called Windows. In Windows authentication mode or in Windows security mode, SQL Server is only capable of authenticating Windows user accounts. Basically, that means you're going to take local or domain accounts, drop them into SQL Server, and you're going to assign access to resources, things like databases or permissions like creating new databases and things like that. You're going to assign all that to Windows user accounts. In mixed mode, you can use either Windows user accounts or you can also use SQL Server login accounts, which is a username and a password that's configured entirely within SQL Server. SQL Server actually takes care of authenticating the person. When a client connects, they have to specify which mode they plan to use, either Windows Integrated or SQL Server, which is usually the mixed mode is what it's called. Now, a lot of environments will prefer to stick with Windows mode, simply because it makes it a little bit easier to manage the security. You're already managing an Active Directory domain. You're already putting people into groups. Why not just use those same groups to assign resources within SQL Server? If you've got a database that your salespeople need access to, well, they probably also have certain files that they need access to, so there's probably already a domain group that they're all in. Rather than just giving each of them permissions, why don't you just assign permissions on the sales database to the sales group? So it kind of makes things simpler. However, some older applications rely on being able to use a SQL Server login. So what you might want to do is say for a lot of our databases, we're going to put them in an instance that's configured for Windows mode, which is a little bit easier for us to manage the security on because we only have to manage it in one place. However, we're going to have another instance that runs in mixed mode. And some of our older applications that rely on SQL's built-in logins are going to run in that instance. So that's another reason to sort of put things together in that fashion. The last thing and the last consideration, and this is really kind of a wrap-up of several of the others, is for compliance. One of the tricks to building compliance, whether you're working with internal security standards or HIPAA for healthcare or GLB for financial institutions or whatever rules you have to comply with, it's kind of nice to be able to put all of your compliant related databases into a separate instance. So in a hospital, this might be patient data. In a financial institution, this might be customer financial information or whatever else. And the reason you do that is because the compliance effort has certain requirements, and you can configure those just on that instance. And that'll include things like security. It'll include things like the auditing configuration. It may include things about the actual database configuration itself in terms of data retention and things like that. You might have different backup and restore requirements that you have to worry about. So by getting all of your data that is affected by the compliance into a separate instance, you can configure just that instance to be compliant. Your auditors only have to look at that instance. And then any other databases that your organization uses that aren't affected by the compliance can be in a separate instance so that they don't have to share the same scrutiny and share the same configuration. So those are some of the planning aspects behind instances. Again, start with the assumption that you're going to have one instance and then expand from there as you look at some of these criteria and determine if you need more instances. The thing you want to be careful of is too many instances. SQL Server is not an infinite thing. You're running it on a computer that's got a fixed number of processors, a fixed amount of memory, a certain finite amount of disk space, and finite network connectivity. Having 500 instances running on SQL Server, probably not going to work out too well for anybody. So that's why I say start with a single instance and then look carefully at the criteria. Don't overdo it on the instances. Now, there's no hard number about how many is too many. It depends on what each of them is actually doing. But that's why you start with one, and then you look to see if you have a good reason to have more than one instance. Next up is storage. I like to start with a couple of basic assumptions. Assumption number one is that I'm going to have some sort of volume that has the operating system and possibly has the SQL Server binary files themselves. I want this to be at least a mirrored drive set so that if something goes wrong, my computer can keep operating. And if you want to have it be a RAID 5 so that it's got a little bit, a little bit better redundancy, maybe be able to get a little bit more use out of your disk space, then you can do that too. But it's got to be some kind of redundant. Mirror is common because it only requires 2 disks, and because although mirroring is a little slower on the writing of data, the operating system and SQL Server typically aren't writing a lot of data. They're just reading that data off disk. Now the only thing you sort of have to factor into that is the operating system page file. You probably, as is a normal performance optimization technique for Windows, you probably want to have the page file written somewhere else, often to a RAID 5. Now if you've got the operating system and SQL already on RAID 5, then you may be able to keep the operating system page files there as well. Now that really has to do with Windows performance optimization, so we're not going to get into it a ton right here in this course. So that's the easy part. Operating system on OneDrive, possibly having SQL Server's binary files there as well. Next, you need lots and lots of storage. And we talked about a couple of ways that SQL can improve performance. Basically, the ultimate way to improve performance with SQL Server is more platters. So as you probably know, hard drives internally are built up of little stacks of platters with magnetic media on them. So what we're saying here is that the more physical disk drives that are involved in the operation, and the more you can spread your data across those, the better. Within SQL Server, you've got the ability to create an MDF database file and then one or more secondary NDF database files. When you do that, you have the opportunity to put those files on different disk subsystems. Usually, but not always, you're going to have those on different arrays, like a RAID 5 array, so that they can survive the failure of a single disk. And then you are going to manually allocate tables, indexes, and other database objects across these. And that's going to do the task of spreading your database across multiple platters. That's the SQL Server technique. Now, that is something that a lot of people use. Sometimes they'll say, well, this particular NDF file, the data we're putting into there never changes, doesn't change that often. Let's say it's our product catalog. So we're not going to put that on a redundant drive. We're just going to put it on a mirror. It's still got redundancy, but it's not RAID 5. It doesn't provide the same performance, but pretty much all we're doing is reading from that. Or maybe we're not going to give it any redundancy at all because we've got so many backups of that if we lose it, it's no big deal. We'll just go to a backup and we're fine with that downtime. And that's a decision that you may want to make. You always, however, want to have your transaction logs, your LDF files, on separate disk storage. A failure of any single disk from your databases must not affect your log files because your log files are part of your backup scheme. That's something we talked about really in nugget number 2 in this series. So that's the SQL Server way. However, keep in mind that Windows and modern storage like Storia Edge networks are already designed to provide a lot of those things. If you've got a huge RAID 5 array and you're dropping your MDF files onto it and you're dropping your LDF files onto it, and this thing is comprised of 12 disks inside of it or some just huge number, it is probably going to do a better job of spreading your database file across multiple platters, because that's what a RAID 5 array does, than you could do yourself by manually allocating objects across MDF and NDF files. In a case like this, where you've got a really rich, robust back-end storage system, you probably are going to stick your LDF files on it, probably going to have each database in one MDF file, and that may be it. And you're just going to rely on the redundancy and the security of that external storage system to do the job of picking up the performance slack, spreading it out, getting lots of platters involved, and providing you the redundancy that you need. So there's kind of 2 directions you can go with SQL Server. And it's a spectrum. It's not a hard and fast decision. At one end, you're going to use a very basic disk subsystem, and you're going to use MDF and NDF files. At the other end of the spectrum, you're going to have an advanced disk subsystem, and you're going to use probably one MDF and have your LDFs on the same one. So at this end, you're really doing most of the work yourself. You're spreading it out, you're allocating it, you're being very careful with the disks. At this end, you really don't have to do that much. You're really sticking everything in one file, putting all the files in one place, and relying on the fact that that disk subsystem is not going to go bad. You know, if you've got a back-end EMC box that's handling your backups and your restoration and your data redundancy and everything else, you may not need to worry about doing anything special in SQL Server itself. So those are some of the storage considerations you need to have in mind when you're planning your SQL Server installation. Now the next section of planning is a little bit easier, and that's security. There's really kind of two unrelated elements of this I want to talk about. The first one is the SQL Server login mode, which we already talked about just a little bit, but I want to sort of stress this. You've got two choices. Windows, which is the default and only accepts Windows accounts. If you're familiar with SQL Server and you know about the all-powerful SA account, that doesn't exist in Windows authentication mode. Then you've got Mixed. Mixed supports both Windows accounts and SQL login accounts. Now, a lot of people who've been working with SQL Server for a long time will always use Mixed. And that's really just because it's what they're used to, not necessarily because they're making a decision. The best practices from Microsoft, and the reason that this is the default when you install SQL Server, is to go with the Windows authentication, and then if you need SQL Server login accounts, to go with Mixed. And my personal recommendation is that if you have one particular database that needs Mixed, it needs to go in a separate instance from other databases that don't need it. That way your security kind of vulnerability surface or attack surface is a little bit separated. Windows authentication is designed to make it easier to manage because all of your account management actually takes place in Active Directory, not in SQL Server itself. The fact that SQL Server still has SQL login accounts all the way in 2008 is really just a testament to how many developers built applications that relied on that model and, in fact, are still doing so. Here's kind of the developer model that leads to that. Let's say we've got an application, and that application is going to be talking to a database that lives on a SQL Server. And that application is going to be in use by a user. Now that user is already logging on to a Windows Active Directory domain in your environment, probably. We'll call that the AD domain. So the user already has a Windows credential. Here's what could happen and probably should happen for better security. The user runs the application on their computer. That means the application has access to the user's credentials. So this is going to be the user's credentials there, the little triangle. And the application simply passes that credential on to SQL Server. SQL Server looks to see if that particular Windows account is allowed to use this database. If it's allowed to add information, read information, delete information, or whatever other permissions it has. So everything is based down here in the Active Directory domain. So that's probably the best way to build applications. Now it's only been my goodness, about 10 years that we've been able to do that. So a lot of developers are still working with the old way. And the old way says something like this. Instead of using the user's domain account, the application is going to have a SQL Server login account hard-coded into it. That means the SQL Server login name and SQL Server password are built right into the application, and that's what the application uses to connect to SQL Server. SQL Server really has no idea what actual users are using the application. It only sees this one standard user account that everyone appears to be using. That means the application itself has to implement its own security. The application has to decide if the user is allowed to delete data or insert new data or archive data or whatever else. SQL Server simply knows that this account has all permissions to do everything, and that the application itself will decide what individual users are allowed to do. A lot of applications are built that way, and if that's the model, then you do need the mixed authentication mode for the SQL Server instance. It's not a great development model, but you do see a lot of it because it's easier for the developer than to deal with the fact that this user permission is going to be passed through to SQL. The user might not have permission, so SQL is going to send an error back, and then the application has to deal with the error. The developers find it easier just to restrict the security at that level. So that's why mixed authentication mode still exists. Now, I said that there were really two security things. The other security thing that we need to talk about are the service accounts for SQL Server. Probably the worst practice is to let all the services run under local system or local service. On a development environment or in a test environment or a lab like we're going to be using here, it's not that big a deal. In a production environment, Microsoft would like you to assign a domain user account to each SQL Server service type. So that's the database engine is going to get an account, SQL Server agent is going to get an account, analysis services is going to get an account, you've got reporting services that's going to get an account. All those different services all get one. And keep in mind, each instance of SQL Server can have its own copies of these depending on how the instance is set up. Typically, you're only going to need one account for all the database engines and one account for all the agents. But depending on your exact security needs, that might not be the case. So you really have to evaluate things. The reason Microsoft wants you to use a domain account for these is so that you can configure them to have the minimum permissions necessary to do their jobs. And if you go back to the nugget number 2, where I sort of discussed some of the security, and especially nugget number 3, you're going to find that URL, and that takes you to Microsoft's most current guidance on what permissions those accounts need. So that's something very important to consider as you're planning your SQL Server installation. Get those accounts set up ahead of time so that during the installation process you can tell SQL Server what account you want each service to use. The last area of planning we need to worry about is availability. Now, there are several things to improve availability that you can do within SQL Server that you deal with after you install SQL Server. Things like designing a disaster recovery plan, designing some fault tolerance into SQL Server. However, some of the things you need to worry about as you're doing the install. One of those is storage. Now, I've already said in this nugget that you need to have your log files separated from your database files, so that if you have a drive failure or file corruption or whatever else and your database files get messed up, you've still got your log files available because those constitute an important part of the recovery options you have. So that's one thing in terms of availability you need to worry about, is your storage allocation. The second thing you need to decide is if you're going to do Windows clustering. Now, this is a decision you have to make before you even start installing SQL Server, because you have to first install Windows clustering services. Now, Windows clustering services is designed to support 2 or more nodes per cluster. The trick with them is that they need to have some form of shared storage. Now, a full discussion of Windows clustering is definitely beyond the scope of this SQL course, but let's briefly talk about what I mean. Let's say this is a server called Server A, and it's a node in a cluster, and this is Server B. We've got 2 important databases that we need to be able to run in our organization. Database A is going to run on Server A. Database B is going to run on Server B. Database A is responsible for about 60% of Server A's capacity. Database B is, let's say it takes up maybe 50% of Server B's capacity. Server A is connected to an external storage system where the actual database files for Database A live. Server B is connected to a separate external storage system where the data files for Database B actually live. In reality, both servers have a physical connection to both storage systems. It's just in the normal state of things, they only look at one of them. So we've got an instance of SQL Server running here, another instance of SQL Server running here, and the instance is going here for its files, and this instance is going here for its data files. Now let's say server A goes kaput. Mission critical database A is offline. What happens? Well, in clustering, we would have installed instance A over on server B, and now server B is going to detect that server A is no longer available, and server B is going to start up SQL Server instance A. It's going to grab onto this external storage, which it was already connected to, so that the instance can see its data files. Now at this point, if you're doing the math, we'll see that server B is actually running at 110% of capacity. That's certainly not ideal. That means performance of both database A and database B are going to suffer, but they're not going to suffer as much as if one of them was available, not at all. So slow is better than gone is basically the theory. So this is the basics behind how this works. When you go to set this up with SQL Server, you have to have Windows clustering already installed on your nodes. You have to have all of your storage already figured out. And you're going to install SQL Server first. Well, it doesn't matter which node you install it on. I like to call it the primary one. I tend to install the instance on the cluster node where I want that instance to spend most of its life. So during the installations, I'll create a new failover node for database A. I will immediately, after that's done, go to server B and install another instance of server A, and I'm going to tell it I'm installing an additional node for database A, so that server B has database A installed. And the installer really walks you through this whole process. So you're going to set up the first node first, set up the second node, and you're able to have multiple nodes running on, or multiple instances running on each node, and you can designate, okay, I want this node to be able to, or that instance to be able to run on that node as well as node C. I want this one to be able to run only on node A or C. So you can kind of allocate these things however you want to. Again, this is a case where it really pays, before you even begin planning the install, to sit down and read the Windows clustering documentation and to read the installation guidance in SQL Server 2008 for clustering. So that's the other big availability thing you need to take into account. Now, again, a full discussion of how Windows clustering works is really beyond the scope of what we can cover here, but if you're going to be doing failover clustering, know when to use it, know why to use it, and that we've covered here, and have a good idea of how to install it. And that's something that you really need to just walk through the guidance on, because it is kind of a complicated process, and the more nodes you have in a cluster, the more complicated things really can kind of get on you. In this nugget, we looked at how to plan for a SQL Server 2008 installation. We talked about the different scenarios for building up instances, deciding how you're going to allocate the instances on a particular machine. We looked at some of the different storage scenarios. We looked at some of the different security things you're going to have to consider, and we looked at some of the different considerations for availability. By considering all of these things in your planning, you can then go on to make smart decisions when you actually begin the installation, so that your installation is set up for success from the very beginning. I hope this has been informative for you, and I'd like to thank you for viewing.